Okay, now integration by parts. This is probably the trickiest thing to use in calculus. It's a technique to do an integral, but it's not doing anything more. So it's a lot like U substitution. U substitution, the backwards chain rule kind of thing, that was for solving really complex integrals where you saw that, hey, there's a U here, and then there's a du outside. So you're kind of recognizing that that a chain rule has happened and you're trying to go backwards. And if you use it, it's just getting rid of this integral. It's just calculating an integral. So same thing here. We're going to be going into integrals that need this technique to solve. But in the end, you need to know this is just a technique. It's not actually like solving a problem. The problem is, how do we do the integral? Anyway, the point here is that this is the form. If you're trying to integrate something that looks like this, there is a shortcut, a technique, where you can do the right side instead. Okay, so let's do an example here, and let's see where would this actually come up. So for example, you want to integrate x e to the x. This is not a U substitution because when you look inside e to the x, this, if you were to think of that as U, well, the derivative then is just 1 dx, and you have this pesky x outside. So it's not like a U substitution. What it reminds me of is the product rule in derivatives. We are taking two functions and we're multiplying together. And unfortunately, we can't just integrate the first part and the second part. We got to use this rule. So the trickiest part here is identifying what's your U and what's your V. So what I think is your U is always going to be whatever will disappear if you do a derivative of it. So if I think e to the x, well, e to the x does not disappear. It just remains the same. Derivative of e to the x is e to the x. So we're going to write x right here. So this right here represents our U. And on this other part here, then this is dv. So this right here represents our dv. First of all, though, let's deal with the u here. In our formula, you're going to need a u. You're also going to have to write du over here, meaning the derivative of u. So let's just write the derivative over here. That would be 1 dx, right? Or just dx. Okay. Now working with dv, to find dv is fine, but we actually need the regular v to keep doing the problem. So dv, we're going to integrate. The integral of just 1 dv is v. The integral of e to the x dx is e to the x still. So now I'm going to take each one of these things and plug it into the formula I see on the right side. So this will be equal to u times v. So that would be x e to the x minus, and yes, we have to do another integral to actually complete integration by parts. So we got that part done. Now for the other part, regular v is e to the x. Du is just dx in this case. So now what happened here was we have x e to the x, and then we have an integral that we can just do without doing this integration by parts. The integral of e to the x is e to the x. And just remember to put the c at the end. Now this could be representing our final answer. That would be fine. A lot of people will factor out e to the x and they will have x minus 1 e to the x plus c. Okay, so that's integrating by parts. This is the integral. Now we haven't actually done anything with it. We have just accomplished integrating. So let's do another one here. Let's say that we need to integrate x cosine of x dx. Okay, this is another situation where we are multiplying functions, so to integrate we need to do integration by parts. And let me write it again up here. This is integral of u dv Alright, so let's identify our parts here. I know that if I integrate x, it'll go away. So it's very similar to the last time. Du is equal to dx. On the other side, cosine x dx, that can be our dv. So dv is going to be cosine x dx. And I got to integrate to get regular v. I'm going to step up. So the integral of cosine x is negative sine x. Okay, now let's plug in what we know. uv will be x and then negative sine of x. I just put the negative in front. We're going to minus the integral of, now our v is negative sine x. And du is just dx. Okay, so there's some work to do here. This is going to be negative x sine of x. And the integral of negative sine x turns out to be cosine x. So this is going to be minus a cosine x. And then we have to do a plus c. Oh, and I realize I made a mistake here. So the integral of cosine is actually sine. So this would be regular sine. I'm sorry about that. The thing that we're going to see here is that the integral over here is going to be negative cosine x. And this negative won't exist. Oh boy. Okay, so now that we've cleaned up the negative mess that we had there, this is actually going to be x sine x plus cosine x plus c. Okay, so that was just doing the integral. The nice thing about this is, if you ever want to check your work, by the fundamental theorem of calculus, if I take a derivative of this, I'll end up with x cosine x. So you can go back and check your work. You just have to do the derivative of this. So, I have one for you to try. Try doing the integral of x e to the negative x dx. Okay, so this is another case where u is going to be x, so du is dx. The idea again is that x is going to disappear after a derivative. And this is going to be dv, so e to the negative x dx is dv. Meaning that v is going to be the integral of this. And you could do it with u substitution, or just think backwards with chain rule. If I derive e to the negative x, it's going to be a negative outside e to the negative x. So if I go backwards, it's going to be negative e to the negative x still. Because if I derive this, I would have to chain rule a negative to get a positive. Either way, this is now our v. So we have to do uv minus the integral of v du. So u times v would be x, and it's a negative, so I'll put it in front, e to the negative x, subtracting, and du is still just dx here. Okay, and one thing about negatives, you can do a plus here because you're taking the constant out. So this will be negative x e to the negative x plus the integral of that. Now, the integral of e to the negative x, we just did this over here. It's going to be negative e to the negative x. And the dx goes away, and we have a plus c. Okay, now here we can actually factor out a negative, well, let me say, this would be a perfectly acceptable answer. But we could factor out a negative e to the negative x, and we would get x plus 1 the negative e to the negative x plus c. That's also another way you might see it written in your solutions.